Thank you, Tom, for the invitation to give an overview of the Exodus story from the perspective of a geoscientist. When I started working on this presentation, it seemed natural to begin from the plagues, since these seem to have some kind of relation to actual geological events. And there are two theories that I came across when dealing with the plagues. One of them is drought. And it's very simply states that during the time of the plagues, there was a drought in Egypt. The drought could have created two things. One of them would have been what's called a red tide, which is the blooming of cyanobacteria and other poisonous microorganisms that would turn the water red. And the other thing that this extreme climatic event would do, it would cause locusts to swarm, and the swarms of locusts could block out the sun, leading to the plague of darkness. The red tide, though, would cause the fish to die and the frogs to leave the Nile River, and together these two things would bring flies and gnats and lice, which would then attack humans and livestock. And this little amorphic blob of plagues could then potentially have caused some kind of poisonous fungi to attack the grain in the grain storage in Egypt at that time. And seeing as the firstborn sons were usually held in high esteem, they would have been fed first, and the firstborn would have, that would explain the plague of the death of the firstborn. The one thing that the drought can't explain, though, is the plague of fire and hail from the sky. Those that believe in this theory, they say there was a freak storm that probably happened at that time, but we don't need a freak storm. Obviously, all of the plagues, including everything that we mentioned here, can be explained by the eruption of a volcano. In the eruption of a volcano, we get the added bonus of perhaps a tsunami, which would then enable Charlton Heston to part the Red Sea and for the Israelites to leave the land of Egypt. Tsunami modeling has been conducted in numerous studies for basically every possible scenario. I don't want to go into the tsunami modeling. This is just a hazard map from 2012 showing the different areas that affect Port Said. So this is a tsunami map for the Suez Canal, showing the potential dangers of each one of these areas and their potential effect on Port Said. This map has been reproduced again and again and again in many papers dealing with the tsunami modeling. And as I said, I'm not really going to go into the modeling. I just want to present, I just want to present one model, which was presented in a paper by Amos Solomon and his co-authors in the book that came out after the first Exodus conference in 2015. And they have a low estimation of the wave heights, saying that they're not very impressive. So Santorini, Thera would have erupted, and it would have taken around 2 hours for the waves to reach the area of the Nile Delta. And the waves would have been not that impressive, only 1 to 2 meters. Let's remember that number, and we'll come back to that in a little exercise that I did in the future. And you'll hear a lot about tsunami modeling, probably from Stephen Ward and Amos Solomon's talk following that. So I started looking at Thera, and I started looking at the timing of Thera. And I remembered this paper that came out in PNAS in 2021. And they presented two chronologies. And what's interesting about this paper is I thought that this was the paper that would solve the dating issue for the eruption of Santorini, because they found two skeletons, the skeleton of a male and the skeleton of a dog. And they dated, you see the little red star beneath the skeleton of the man. They dated this, and they found that two possible dates exist. They have the 1612 to 1573, what they call the high chronology, and 1565 to 1501, which is more probable, and this is the low chronology. And I thought that was it. The dates have been solved. But when Tom sent me on this task, he didn't realize the depth of the rabbit holes that I would go down. And I found papers that have been published since then, and each presenting a different range for the eruption of Thera. So we have 1606 to 1588, 1609 to 1557, so on and so on. And finally, the last paper that I managed to find from Manning 2024 says that it's most likely to be dated to 1611 or broadly around 1600 BCE. With the earlier dates of 1561, unlikely, but the latest even possible alternative. Now, I'm not a biblical scholar, and I know that there's a huge issue about the dating of the Exodus. We just heard that in question to Brad before. I've taken the two dates that I was provided with, and also by searching on the internet, of 1446 BCE or between 1270 and 1250 BCE. And based on these date ranges, I can say that there is not a smoking gun, and Thera is not a smoking gun, at least in terms of the geology. So to try to solve this, I looked at what the possible where could the Exodus have happened, and I started with the traditional locations in the Red Sea. And again, I'm looking at it from a purely from the point of view of a geoscientist, somebody who deals with seafloor morphology and tectonics and earthquakes on a daily basis. And I started with number one traditional location, the Gulf of Aqaba or the Gulf of Eilat. And we can see just by looking at the depth map today, again, this is the depth map today, not 3,000 years ago, but assuming that it hasn't changed that much and that assumption is pretty well backed up. We're talking about a very deep basin. There is no land bridge that I've seen papers that have proposed a land bridge near Nueva. It doesn't exist. We're talking about depths that are a minimum of 500 meters, which is really deep water, even for, let's say, a tsunami wave, definitely for wind set down, which we'll talk about in a second. But there are two, just by looking at this map, two possible areas for the Exodus. One of them is the Strait of Tiran, and the other one is the head of the Gulf. The Strait of Tiran, this is a nautical map. It's a little confusing, but you can see the little number that my arrow, if you can see my arrow, 241. 241 is 241 meters. That is the narrowest point in the Strait of Tiran. Again, we're talking about an area that's way too deep to provide any kind of dry land for the Israelites to cross out of Egypt, given a natural phenomena. And the other possibility is the Gulf Head. And the Gulf Head, we can see that we do have shallow water of around 10, 20, 30 meters maybe over here. During an extreme event, that's an extreme tsunami event, possibly, maybe we could have dry land in the area over here, but then that kind of begs the question that if the Israelites were going to cross the Red Sea in this area, why didn't they just go around? Why would they cross over here? But I'll come back to the Red Sea in a few more slides. The Gulf of Suez has also been proposed as a possible crossing site. We're also here dealing with deep water down to 75 meters. The shallowest being this blue over here, 40 meters at a stretch, 35 meters. So the really only possible site that makes sense has been suggested before as the Suez Bay. This again is a nautical map, and we can see that it's hard to see the numbers here, but this first contour line over here is 10 meters. So the darker blue is shallower than 10 meters, meaning that this area over here is a possible connection, at least looking at the water depths today. But I admit that I did steal a picture from Carl Drew's website where he posted a map of the Suez sorry, the Suez Bay before the construction of the Suez Canal, and water here was deeper. This is the 10-meter contour, this is the 20-meter contour, and all of a sudden this area that today could be dry land given a tsunami with a wave run up of 10 or 20 meters, it would be dry land, can no longer be dry land because we're talking about 40, 50-meter water depths in these areas. So um, the traditional location for the crossing of the Red Sea is somewhat questionable in terms of the geology. Now, admittedly, this is the water depth in the 1800s. I have no idea what the water depth in this area was 3,000 years ago, and that's something that I think that we can't know. But there's a plethora of research that has come out on instead of saying the Red Sea, the Reed Sea, and the lakes that are in the Nile Delta. And there's a series of lakes. Each one of these is a red star, has been proposed by different authors to be the biblical location of the Exodus. And I asked you to remember that number 1 to 2 meters that Amos proposed for the wave run up for the Santorini eruption. And oh, sorry, just before that, I just want to say that the other mechanism for that has been proposed for the parting of the Red Sea is not a tsunami. It's been wind set down, and I'm sure that you'll hear more about this in Carl's talk. But basically, what it says is that if you have a strong wind blowing for long enough, it's going to push the water away from the land, and you'll have this area of dry land where it might be possible, if it's shallow enough, for a crossing to occur. This was modeled by Nof and Paldor in the 1990s for the Gulf of Eilat and the Gulf of Suez. They showed that it could only, such a wind set down could only develop from a north-south blowing wind, but the Bible specifically says that the wind blew from the east. So it's not good for the traditional locations, but it is good for the lakes in the delta. And here we come to that 2-meter number that I said before. And this was just an exercise that I began one evening. Unfortunately, was cut short because I had to run down to the bomb shelter and I didn't get a chance to come back to it. But this is what a 2-meter high wave or a 2-meter increase in sea level would look like in the present day Nile Delta. These are just two different models. They're more or less in agreement with each other. There are some differences, but nothing that sticks out too much. And I know that this was not the morphology of the delta 3,000 years ago. At the bottom, there's an example from 2019 where the dotted line is the present day morphology, and this is just a sketch of a possible morphology from coring data for the period between 3,000 and 6,000 years ago. I know the morphology is different today, but it was just an interesting exercise to play. One thing I do want to stress is that we don't need to have a regional event. We don't need to have a regional event like the eruption of Santorini of the Thera volcano. It can be a local event, and all we need is a sediment load in an area that has an active fault. And when that fault erupts, the sediment is slides downwards, creates a submarine landslide. It pulls the water down, allowing a dry area where the Israelites could have crossed. Water rushes to fill the space, and it creates a swell wave or a tsunami wave. So we don't have to look far. We can look close. And looking close by, these are the faults offshore Israel. The light blue faults are on the continental slope. The dark blue faults are the faults that have been mapped in the deeper basin, the deeper Levant basin. And looking at what's going on in the Nile Delta, we also have submarine faults in the delta itself, around the delta, active faults, sorry, on the delta itself, around the delta, and offshore the Nile Delta. So faults we have. We also have landslides. This is a paper by Urgelis and Kamarlengi, sorry, from 2013, where they mapped the landslides in the Eastern Mediterranean basin. So we have the Israel slump complex over here, and we have these huge, huge landslides. Now, the 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 dating on these landslides is everything from a couple of million years to a couple of thousand years. I haven't had a chance to go in and examine the exact dating precisely. That's something that I plan to do in the next stage. The question is, do we have earthquakes, though, that correspond to the time frame that we're talking about? And in order to examine this, I turn to the high resolution record that we have at the Dead Sea. The Dead Sea is a terminal lake, which means that it has an entrance and it has no exit. And what that basically means is that anything that gets into the Dead Sea stays in the Dead Sea. So we have a very high resolution record of climate as well as earthquakes. And why do I say earthquakes? Because when sediment is deposited in a lake, it's deposited horizontally. So these horizontal layers are normal deposition in the lake. But the minute that the ground is shaken, let's say during an earthquake, we start to get structures that are folded on themselves and broken layers, and these are called seismites. And if we can date the layer above and we can date the layer below, we have an age constraint on this earthquake, which can then be correlated to historic earthquakes. And this has been done in the Dead Sea for the last 20 years or so. And this is a record of one of the cores, and we see that we have dates that correspond to 1100 BC, 1365 BC, 1560 BC. We have earthquakes, just not exactly at the right time, according to the dates that I showed you before. And on the right-hand side, we see magnitude. The x-axis is the magnitude of the earthquake. The y-axis is the distance from the Dead Sea itself. And in red, that's the earthquake of 1365. And I brought this here just to show you that the Dead Sea records earthquakes of, I'm going to say, medium to strong magnitude, but from thousands of kilometers away, hundreds, if not thousands of kilometers away. So we really do have a good record, a well-constrained record of earthquakes in the Dead Sea. The one thing, though, that is important to mention is that we don't need earthquakes. We can get submarine landslides simply by climate change. And here is a paper that is unrelated to the Exodus, but was published 2 years ago, climate-controlled submarine landslides on the Antarctic continental margin. And the idea is very simple. When you have climate change, you have fluctuations in sea level. Fluctuations in sea level put more pressure or less pressure on the sedimentary load. And if we have a period where sea level is low, that means the hydrostatic pressure on the sediment load is released and the sediment can slide. If the sediment can slide, it can create it can pull the water behind it, like we saw in the scheme that I showed before, in the picture that I showed before, and creating a wave that can't be defined as a tsunami wave, because a tsunami wave by definition has to be attached to an earthquake, but a tsunami-like wave. So the question is, do we have climatic fluctuations during the period that we're talking about? And going back to the Dead Sea and looking at the lake level curve. So this is the lake level curve from 10,000 years ago all the way to present. And we see that right about the time that we're talking about, there is a drastic drop in lake level. Sorry, there's a drastic drop in lake level of over 50 meters over a very, very, very short period of time. So we do have climatic fluctuations. And looking at what's happening in the Levant basin, so offshore Israel. On the left-hand side, this is from a core offshore Israel, a paper that was published in 2013. Again, looking at the dating of the Exodus. And looking at the top three graphs, starting from the third one from the bottom right where my pointer is. This is the Blue Nile flux, and we have the White Nile and the Blue Nile. The White Nile is the supplier of the water. The Blue Nile is considered to be the supplier of the sediment. So we have an increase in sediment supply or an increasing sediment supply during this period. It's becoming more fluvial, so it's becoming more dominated and less dust input. And maybe Gal will talk about this, I don't know, in talk that's following mine. And it's becoming more heterogeneous, so it's becoming more land-based. So something is happening to the Nile during this period. And we also see this in the Buralus Lagoon, which is the lagoon in the northern tip of the Nile Delta, where also from a core, they see an increase in Nile flow at this period. An increase in Nile flow, increased sedimentation, can lead to instability, sediment instability, sediment load, and again, that landslide that's not connected to an earthquake necessarily. What I started to do and was didn't have much time to develop it, unfortunately, was look at the latest papers that are coming out of the area. There's not a lot of data, but there are some papers that are coming out. And this is a paper that presents a core from the western part of the Nile Delta. You see over here on the right-hand side the location of the core. And again, at the time of the dating of the Exodus, we do have a paleo tsunami deposit. And here's a paper by Amos Solomon. He and his co-authors, they modeled a potential tsunami occurring at the head of the Gulf of Eilat. So the star would be where the landslide occurred, and the white dashed line would be the two profiles that the one profile, it's one profile in one area that's been enlarged, the one profile over here. The wave run up on the eastern shore is in blue, the western shore is in red, and we can see that the wave run up from this tsunami can reach 7, 8 meters after 2 minutes and 6 seconds, and we're still at the 10 meter, 8 meters after 10 minutes, 10 and a half minutes. This is the area, so this would be the sediment that was removed in the landslide, and this would be the wave. This little dip over here is enlarged over here, and we do have a range of 10, if not 15 meters in this area. Which is interesting because looking at Tel El Khalifa, which is an area that has been intensively developed over the last few years for the Isla Oasis, which is over here. A master's thesis by Janet Smith came out in 2020 where she examined a series of trenches in the area, and the picture on the right-hand side is from TX4, which is this little red trench over here. And her conclusion was the bed forms and organic material color and sediment size of the channels at the Isla Oasis suggest evidence of a tsunami, which likely occurred between 3,300 and 3,100 years ago in the period that we're talking about. Again, not getting into the debate over the dating of the Exodus, although it is important here. Bektas et al. From last year examined 18 cores in the Gulf of Aqaba. The longest core is core number 11. It was cored over here, and also there they find evidence for a turbidite. A turbidite is that flow of water that is pushed ahead when you have a submarine landslide. So it's connected directly to a submarine landslide, and the light blue is the lower chronology for the Exodus, and the dark blue is the higher chronology for the Exodus, and it could be connected to the 1350 BCE earthquake or not. We don't have a lot of data as of yet. What else can be done? Well, as a geophysicist, obviously, we look for geophysical data. So this is the geophysical data from the Gulf of Eilat, from the Gulf Head. This is what on top you see an uninterpreted section. At the bottom you see the interpreted section. And if we want to examine the period that we're talking about in geophysical data, we need data that's even higher resolution. We need the top 10 meters. Today we have the tools to do that. And we need to combine it with the correct proxies from our coring data such as those suggested by Ashmore in 2022, foraminifera as an indicator of landslides, not just of paleotsunamis. We also have the ability to collect geophysical data in harsh areas and dried up lake beds. This is an example of a survey that we were conducting on the dried out part of the Dead Sea on the salt itself. So we have these capabilities. I have two more slides. I'm circling back to the plagues. So what I started with, the drought and the volcano, at least in terms of what we are seeing from the papers that are coming out now, are not really a smoking gun in terms of geology, and we have to go back and re-examine these again. So my initial assumption that these were reasonable, these had reasonable geological explanations is somewhat debated in my own head at the moment. I don't have time to go into oral traditions, so I'll skip that. I just want to end with, where everybody's talking about the Exodus now. Even the ambassador, the American ambassador to Israel, tweeted on Saturday something that's related to the Exodus. Operation Exodus is helping U.S. citizens evacuate Israel. We can't part the Red Sea, but we are parting the red tape to help people who wish to leave. So this metaphor is very strong in our memory, and I will leave you with that. Sorry, I'll leave you with that. So thank you very much, and that's the end of my presentation.
Thank you, Michael. Michael, do you hear us?
Yeah, I can hear you.
Perfect. So I think we have time for a few questions. Yeah, Tom.
Hi, Michael. Great to see you.
Hi, Tom.
Great talk. How far
Thank
is Tel El Khalifa from the coast at the northern end of the Wadi the Aqaba, Gulf of Aqaba?
Yeah, that's actually a good question. I'm not sure the exact different distance. This is 2 kilometers, so I would say it's a couple of 100 meters, maybe half a kilometer up to a kilometer away. I can look into that though.
Hey, Michael, Neil here.
Hi, Neil.
I've been looking a lot into Ezin Geber or Tel El Khalifa for a while now.
Yeah.
If we use Dick Friedman's metric of connecting it to the Bible, we do know that Ezin Geber was a much later stop on the Exodus journey. So it suggests that probably is most likely not where they are crossing, just because we know it's specifically mentioned later.
Sure.
So that's maybe one thing, but actually your work in the Gulf of Aqaba, or the study of the Gulf of Aqaba, makes me want to ask the question, the places that we do have a higher suggestion of where they could have been crossing, like the lakes and others, has there been any coring there to suggest that there might have been micro tsunamis that occurred or mudslides?
There's been a lot of archaeological work done, obviously. I have not come across any papers that presents coring data, nor have I come across any geophysical surveys. And I think we're trying to put some kind of geological context to this whole story. I think that if we somehow had the capability to core there as well as conduct some geophysical surveys, I think we could answer a few of the questions that are arising from this conference and will be brought up later. I haven't come across any studies though. No.
Yeah. Okay, great. Thanks. Well, that's great because that gives us an idea of where to look next, right? Yep.
Definitely. We have the tools.